It's taking longer than we thought to build this amazing telescope, partly because we never built one before like it. It is enormous. The sunshade that we have to build is as big as a tennis court. It has to be folded up really small so when we get it up there, it can unfold properly in outer space. We have to rehearse and practice, and we have to find those little mistakes that people always make and fix them. So it's difficult, but it's worth it.
These recommendations are all designed to create mission success, to enhance the likelihood of mission success. And therefore, we're accepting all recommendations. We're going through it and taking every one of these recommendations over and above what we already were going to do and implementing them to the best of our ability. What we're going to do now is push through that integration and test. We're going to shake it, blast sound at it, heat it, cool it, and make sure that everything is working exactly like it should. This is the hardest time of the development of any spacecraft, but also is the time that gives you the certainty that at the end, this mission will be successful once deployed in orbit.
We do risky things because it's the only way to get at the answers that we're after. You can't say, I don't really want to know, because we do really want to know. But the only way to get at the answer is to build this kind of equipment.
So Webb constitutes a big leap in astrophysics. It really is the next generation telescope, a telescope we've never seen, an observatory that nobody has imagined before Webb. And whenever we do that, it's difficult.
In order to discover the things that we have never seen before, we need the best equipment we can possibly have. So the telescope that we're building has no substitute. There's no other way to get at this scientific discoveries that it'll make. What it'll really find that we don't know? Well, I don't know. It's a mystery. So we build these telescopes with great confidence that we will open up new mysteries of the universe whenever we build them. It's happened time after time after time for centuries. We are looking for our entire history. How did we get here from whatever it was that came before? So we know about the expanding universe, which we call the Big Bang. It was very hot, very compressed. Somehow that turned into us. How did that happen? We know the stars and galaxies formed somehow, billions of years ago. We know that they're still being born today, not too far away. We'd like to know how planets become habitable. How do they come out to be just the right size and temperature to have just the right amount of water and oceans and continents so that they could be like Earth? All of these things are huge questions for humanity. And I think everybody wants to know where did we come from, and I especially do, because it's like the most difficult and interesting challenge in science.
Webb is all about making history. It's about United States leadership in astrophysics in the next decades. And it is therefore very difficult. If making history was easy, everybody would do it. But it's surely worth the wait.